All right, so I'm Dr. Pedicolis, Laura Pedicolis, and I work with Professor Kaminsky as the Associate Director of the Edion STEM Learning Center or Department. And we met Megan after Professor Kaminsky and I advertised some jobs that we had open in our group. And she reached out because she was interested in our projects. So one of our projects is related to a new NASA research center called the Mock Center. And its primary focus is to look at whether magnetic fields are important to protect atmospheres and thus important for the habitability of a planet. And we're working on that project with the Fisk Planetarium in Colorado on this to use spherical displays to communicate our work with the public. And our plans had been to do some work on that and try to understand what the public felt about seeing this information on a sphere. But of course, with COVID, we had to change our plans and the presentations on the sphere went to virtual presentations. When I was talking to Megan, she said that her career goal is to work in a museum or science center, kind of like the Exploratorium or Cal Academy in San Francisco. And that made me very excited because I do a lot of work with museums and activities that happen in that kind of outside the classroom arena. And Megan, when she learned about these virtual spherical display shows, she was interested to learn if they were actually effective or not as a learning tool. And that seemed perfect for her capstone. So I just want to say that working with Megan has been just completely delightful. She had to go through some really complicated internal review board processes to ensure that the research is compliant with federal laws and SSU policy. And I see Jesse nodding. Yes, some of you have learned about this very tough and huge amount of time, this process. It just is really tough and it takes a lot of time and a lot of learning. About federal laws, science education research. What really impressed me was Megan was so persistent and resilient again and again with incredibly frustrating emails and processes just to be allowed to advertise the survey she'd created and implement the research process she developed. So you'll get to hear all about what she came up with and how she did it. And I'm just really impressed with all the work that she did to learn about how to do science education research. And I think that she will land very well into a career in a science museum because they're always looking for people with these skills because it takes a certain personality. All right, so, and just like a lot of the projects today, this will continue, her work will continue and she'll work with us over the summer as she's looking for other jobs. So we're excited to keep working with her. All right, with no further ado, Megan, please take it over.
Thank you, Laura, for that introduction. All right. Okay. All right, so good afternoon, everyone. My name is Megan Miller, and I've been working with Dr. Kaminsky and Dr. Petikolos on my Dome to Home survey. So what is Dome to Home? So like Laura was talking about, many planetariums are attempting to do virtual shows in lieu of in-person ones due to COVID-19. So Dome to Home is a web series that was created by the Fisk Planetarium at the University of Colorado Boulder that explores a wide range of astronomy topics, including Mars exploration, exoplanets, and life on other planets. They're generally geared towards fourth to eighth grade students, but are interesting and accessible to everyone. Their March series, which is the one I focused on, focuses on water in our solar system and why it's important to our search for other life. Here on the right, I have the Fisk Planetarium logo, as well as a screenshot from one of the Dome to Home episodes. So to go into a little more detail about their March series, episode 1 will dive into the wide variety of places water can be found in our solar system. Episode 2 asks the question, where did all of the water in our solar system come from and why is it so abundant on Earth? Episode 3 explores how we even know there's water on other planets, comets, and moons. Episode 4 answers the question, why do we even care about finding water on other planets? And finally, episode 5 will describe how there's evidence that Venus and Mars also had oceans of water like Earth does, and how magnetic fields may be a possible answer as to why Earth is the only planet that has oceans of water left. Episode 5 also includes a special guest, Dr. David Brain, who is the principal investigator of the MOC Center. So MOC stands for Magnetic Fields, Atmospheres, and the Connection to Habitability. And this is partially what motivated my project, as well as the grant that we have for MOC, which is doing research into the role magnetic fields have in the development of life. So my project is to research the efficacy of virtual planetarium shows as well as Science on a Sphere shows as a substitute for in-person shows due to COVID-19. To do this, I've created a survey for the viewers of these Dome to Home episodes to give their feedback and answer questions on each episode they watched. They will answer at least 2 open-ended questions, 4 feedback questions, and 6 demographic questions. The open-ended questions will be used to gauge how well the viewers are retaining the information in this virtual format, and the feedback questions will be sent to the FISC staff to help improve their future Dome to Home videos. So to go into a little more detail about what Science on a Sphere actually is, Science on a Sphere is a 3D spherical projection system that's used as an educational tool for Earth or planetary sciences. They often include animated images or videos of storms, climate change, land, really anything that you would want. This picture here I have on the right, I took at the Museum of Science and Industry in Chicago, showcasing climate change on our planet. So Dome to Home is trying to transfer these 3D shows into a usable 2D format. So here I just have a quick clip from one of the episodes in this March series.
So here we are at Enceladus, and you might notice, wow, that does look a lot like Europa. They're very, very similar. Enceladus also has ice on the outside and water on the inside. And we know this, again, because of a spacecraft, not the Galileo spacecraft. This one was called Cassini. Cassini is very, very famous because it was out orbiting around Saturn for more than 20 years. It was there forever. And we learned so much cool stuff about Saturn and all of its moons, but in particular about Enceladus. There's a little Cassini, hello. Now, one of the coolest things about Enceladus and Cassini is that because of this, we know that Enceladus has geysers. The whole South Pole is really, really cracked, and it's shooting water out of it hundreds of miles into space. And so there's these huge geysers that are erupting from the South Pole of Enceladus.
Oh, no. There we go. Okay, so another thing that I also did is that on the MOC website, I created a landing page that has all of the information for people who are interested in taking my survey. It has the links to all of the videos, as well as information on the raffle that they can enter, and the link to the survey itself at the bottom of the page. So to take a little bit of a closer look at the content questions that I am asking the viewers, depending on which episodes that they watched, you know, they could have just watched one or they could have watched all of them. They will be asked these content specific questions. So if they watched episode 1, I ask, what are the 3 states of matter that we can find water in? Episode 2 is, where do scientists think Earth's water came from? Episode 3 is, what is one way scientists have been able to learn if an object in our solar system has water on it? Episode 4 is, why are scientists interested in finding water in other parts of our solar system? And finally, episode 5, I ask, why do we think Earth's magnetic field is helpful for keeping our oceans? So to go into a little more detail with my work with the Institutional Review Board, or IRB, after I made this survey, I needed to get it approved by the IRB board because I was working with humans in this study. So the majority of my semester was spent with lots of emails communicating back and forth, trying to get this approval for my survey. I had to make many, many edits and changes to consent forms and my applications for people who were over 18 and under 18. So I learned a lot about the efficacy of surveys like this and research with human subjects. After many, many months, my 18 and over survey was finally approved, but I am still working to get my under 18 survey approved. And unfortunately, due to the late approval of my over 18 survey, I've only received a couple of responses, so not quite enough to review in this presentation. But some of my next steps is that I will continue to work on this project over the summer, and hopefully I will get that under 18 survey approved. And once I do have more responses to either one of the surveys, I will then present them to the mock team. Finally, I'd just like to give some acknowledgements to the Dome to Home staff, specifically the 3 people here I have listed, as well as Dr. Laura Peticolas, who has been so helpful this whole semester, and she's never complained about all of the emails I've sent her asking for help. I also want to thank, again, all of my physics and astronomy professors I've had over the years and all of my classmates. You've all been so helpful, and I couldn't be here without all of you. Thank you.
Thank you so much, Megan. Let's see if there's a question or two. I see Alex popping her hand up right away. Dr. Miller?
Thank you, and great talk, Megan. So when you do eventually get more data, I assume you'll want to quantify it in some way. Do you have a plan for, because I know they look like short response questions, so are you going to like you'd get 4 points for this particular response and that would be the best, or do you know what your plans are for that?
So what I've been imagining in my head is that for each of the episodes, I have kind of an expected response for those, for the episode, like what I think the most important information from those videos were. So when I do get those responses, I'm hoping to see the similar things that I was expecting to make sure that the content's actually coming across clear enough.
Great, thank you.